Welcome everyone to the first Hacks at Cambridge workshop of this term. So we have just a sort of logistical thing before we get started. There is a worksheet for this workshop which will sort of guide you through all of the stuff we're going to be doing today, and you can access that if you go to hacksatcambridge.com/workshops. You'll see a link to the workshop we're going to be doing today. So, today we're going to be talking about continuous integration. So, let's talk about first the things that you need. All the requirements are online, and hopefully you guys have gone through this before, but if you haven't already, now is a great time to make sure you've got Gradle installed, Git installed, Java installed, make sure you have a GitHub account and a text editor. So I'm going to talk briefly about what we're going to cover today. I'm going to explain to you first what continuous integration is, and give you a bit of an idea of what needs to be achieved before we have a continuous integration workflow, what else, sort of what that means like in practice, and what the benefits are of that. There are also some downsides. And then later on in the workshop, we're going to actually set up a continuous integration workflow ourselves and get hands-on with Gradle and Travis. So let's get started. What is continuous integration? Well, if you were to go to Wikipedia and look at the definition there, you'd see that it says, in software engineering, continuous integration is the practice of merging all developer working copies to a shared mainline several times a day. And I mean, it's true, but that's also pretty incomprehensible if you haven't heard of CI before, and it doesn't really tell us a lot of things. Firstly, what continuous integration actually is, and what it's trying to achieve and solve, how we go about doing continuous integration, and then what the consequences are of that. Continuous integration is solving integration problems, and that is the idea of, well, I mean, it's best to explain it in a scenario. So you're on a team of developers and you've got a deadline coming up and you're all working on different features on this project that you're building. And as the deadline sort of gets closer and closer, you've all got to sort of merge your features into the main code base. But maybe something that you do is sort of getting in the way of something someone else is doing, and it's breaking other things. And you've got very little time to do this, and it's all of a sudden become integration hell. So that's obviously not good. And if you find that sort of hard to relate to, one way of thinking about it is it's kind of like putting on a play. So as you're sort of learning your lines and building new features, you might make sure that you know them off by heart. But if you're not constantly rehearsing the scenes with other people and getting your cues right and doing it with props and stuff, then by the time you get to the looming deadline of doing the play for the first time, then it's going to be an absolute mess. And the way you'd mitigate that in that situation is you'd have lots of rehearsals with other people, with props, and you do that constantly throughout the whole sort of process of learning. And continuous integration is all about doing that. It's about sort of making sure that we're constantly testing and compiling our code and make sure it sort of does what we want it to do. And that sort of is what we're going to talk about today. And yeah, this is again the analogy of it being like a play. So, what do continuous integration systems require? Well, we need a build system. What's a build system? A build system will take your whole project and it will make sure that everything compiles. It might run tests. It will sort of pull in extra code from elsewhere that you need it to do. And depending on the specific build system, it may do more or less than that. But essentially, that's what a build system is. And Gradle is what we're going to be using today, and that's our build system. We also need a way of testing systems, so running unit tests. These are sort of very small tests that try to make sure that the smallest sort of logical blocks of your program are running exactly as you'd expect them to, and also sort of larger tests as well. And the thing about these build and test systems is they both have to be quick and easy. So if you've got a very large code base, you don't want your tests in your build to be running for sort of hours and hours in order to compile an app. In my group project, I think it took up to 8 minutes to build just a simple Android app, which is unfortunate, but it could be a lot worse than that. I mentioned unit tests. You've got to make sure that your unit tests are up to date. If you make sure that they're doing, they're testing the latest version of your code, then that's fine. But if you've built something new and you haven't written the test for it, then it's very likely that if it breaks, you won't see that until much later on. And that means that it will cause an error, which will cause an error, and you have this sort of trail of errors that you kind of have to follow, and that's a bit of a nightmare. And you also have to have good version control. So cool. And then what are the good things about this? Well, I mean, regularly testing code is a very good thing. You can also do sort of automatic deployments. So if you're using maybe like Heroku or something, which is a web service for hosting websites, when you push code to your GitHub repository, it will automatically test code, and if your tests are all fine, then it will make sure that website is updated, which is really nice. You can also have emails sent around to your whole team if someone breaks something. I mean, maybe that's not something you want if you're trying to have like a good working environment with low pressure, but maybe it is. It's a nice thing to have available, certainly. You can also have Slack integration. So who here has used Slack? Okay, pretty much most of you, yeah. So if you're unfamiliar with Slack, this is kind of what it looks like. It's like Facebook Messenger on steroids. This is pulled from our Hackers at Cambridge Slack, and you can see here, GitHub is telling us about all the stuff that's happened. So people creating new issues with our website, any new code that's been merged in. We're getting a constant feed of what's happening. So that's really nice. You can create builds daily. So if you have a product and you want to make sure that your customers have the latest version of that product alongside maybe a stabler version, then you can do this automatically without even thinking about it. If any of you came to the Rust workshop, you'll know that there's a Rust nightly version, which is something that's the newest compiler for Rust and built nightly. That's where the name comes from. And I know a lot of other systems do that too. And the last bonus is that easy build systems make it very easy for new developers to sort of get on board. And this is maybe sort of seems like kind of an innocuous point, but if you have maybe like a setting on your computer that's making your code work on your computer, then you may not know that, but like it's happening, and you can push it up to GitHub or to your central code base, and then a new developer might sort of get that code, and all of a sudden they don't have that setting and it's not working for them. And the nice thing about having sort of a centralized build system on a clean slate is that it will be able to detect that problem as soon as you put it into the code base. And you're not going to have confused developers who are like, oh no, it's telling me I haven't got this setting set, what do I do? And that's actually really, really useful in a team. Cool. So let's talk a bit about Gradle. So I mentioned earlier what a build system was, and Gradle is one of these. And if you sort of go online, you get this this wonderful long spiel about emerging from build hell today through Gradle build tools, and it's kind of sort of horrific to read. And today we're just going to sort of dive into the how to use it. The main reason we're using it here is because whilst it supports many languages, it has pretty good support for Java as well, and you guys will all know Java. So let's get stuck in with Gradle. This is where we actually get into the hands-on part of the workshop. So what I want you guys to do is open up a terminal. And can you all read this, by the way? Can I make that bigger? And seeing as you've all got Gradle installed, in order to set up a Gradle project, it's very easy. So I'm going to go into my documents. I'm going to make a directory called Continuous Integration Workshop. And I'm going to open it up. And then what I'm going to do is I'm going to write Gradle init -- type Java - library. And so what this is doing is it's telling Gradle to set up a project for me and to do it so that it's of the form of a Java library project. And you can see it will go away and do stuff. Is there anyone who's having issues? So what I'm going to do now is I'm going to go into my text editor. I'm using VS Code, and I'm going to open up that directory that I've just created. Then we're going to just take a look at some of the stuff that Gradle has done for us. So you'll see we have this build.gradle file, and it has a few things in it. So build.gradle is something which tells Gradle what it needs to know in order to build your project. So here it's telling us we've got this plugin, which is something that you'll use as a developer, so it's something to help you as a developer. And it's just telling us that this project is a Java library, and that means that we can tell Gradle to do things like compile, and it will know to go off and find your Java code, which we'll see later is located here in this folder, and it will know how to compile it, and it sort of does that all with us out, even we don't need to worry about that. So that's lovely. We've also got this dependencies thing here. Now, a dependency is a sort of piece of code that your code needs in order to work properly, but it's not code that you've written, it's like someone else's code. There are these 3 different types of dependency which are defined here. So an API dependency is a piece of code that you use that you want your end users to use. So say, for instance, I'm writing a maths library to do, or a graphics library, say, to do things on screen in Java. And for that, I want to be able to use some maths functions, and I want to do matrix multiplication and whatever. And I might want to use a library that does that for me, so I don't need to write that code. If I want the end user to also be able to use that matrix multiplication library, then I put it here in API. Maybe I don't want them to use it. Maybe I just want it to be me, and they don't need to worry about matrix multiplication. In which case, I'll put it after this implementation tag. And then also, you get dependencies, which you just want while you're testing. So here we've got test implementation, and this thing called JUnit. So basically, it's just something that helps us run tests, and specifically unit tests on our code. And we'll be diving into some of that later. This last thing, very quickly, this repositories little area is basically just telling us where we can find our dependencies, and it's as simple as that. JCenter is just somewhere online where you can go and look up dependencies. So that's great. That's build.gradle. We also have these Gradle W things, which if you open up will look absolutely horrific. And the nice thing about Gradle W is you don't need to worry about it. The reason we have this is so that, say I'm a new developer and I want to get started on this thing that we've just built. I download the code, but I don't have Gradle installed. Well, Gradle W will sort of download and invoke a specific version of Gradle, the one that we sort of have specified that we want Gradle to use, or the one that was used to build the project. And that means that you don't have to go through the sort of tedious process of setting up Gradle before you then get started on your project. Everything is sort of done for you. It's bootstrapped. It's lovely. And so we don't need to worry about what all of this is doing because it's automatically generated. So that's Gradle W. And the reason we have 2 here is for Unix and Windows systems. Then we have settings.gradle. Not incredibly important at the moment that we look into this in detail. It's just basically telling us what the structure of our project is. And then the last thing is, as I sort of alluded to earlier, we have this source directory. And in it, you'll see that Gradle has created these 2 files for us. One is called library and one is called library test. In this library, we have something which is some library method which always returns true. And we have this test here, and we'll talk about this a little bit later, that's basically just making sure that that method is always returning true. So that's pretty cool. You may be thinking, oh no, not that. You may be thinking, can we actually just get started and doing something now? So let's have a look at what we can actually do. I'm going to go back to my terminal. And what you can do is you can type Gradle Build. And what this is going to do is Gradle's going to go and it's going to, you'll see this says compile Java right now. It's going to make sure that all of my Java compiles. It's going to run some of my tests. And then if all of that goes well, then it will, my build will pass. My build will be successful. And you can see here that that's exactly what's happened. This sort of nice green is very reassuring. If you want to reassure yourself that it's actually sort of compiling the Java properly, then you may want to go into this library take away some brackets, so that we've now got invalid Java syntax. If we go back to our terminal and type Gradle Build again, then it should be unhappy. Yep. And you'll see here it's telling us, go to library.java, line 7, and you'll see that you're missing the end of the file. And so that's great. It's giving us some feedback there. So I'm going to put that back, and now it should build again. All right, wonderful. So while the rest of you guys are sort of getting that fixed, I'm just going to sort of swap out this kind of boring method here for something a little bit more interesting. So everyone knows, Fibonacci numbers are a thing and they're often used in workshops. So I'm just going to quickly write out an iterative version of the Fibonacci method. And this is all on the website again. So if you go to hacks@cambridge.com/workshops, you can copy and paste this code in. But yeah, so what I'm going to do is I'm just going to check that and if it's less than or equal to 1, then we know that the Fibonacci of that will always be the number itself. That's wonderful. Oh, sorry. I need a parameter. And then the next thing I'm going to do is I'm going to define this thing called fib, which is going to be a sort of a running number of what the current Fibonacci number is. And I'm going to also have a previous fib, which I'm going to set to 1 to start off with, which is going to effectively be the previous Fibonacci number. And in order to calculate the next one at each iterative step, we're going to add them together. So I'm going to do for int I equals 2. I is smaller than n at I plus plus. Int, going to define a temporary variable to be equal to fib. I'm going to update fib with the previous one, so I'm adding them together. And then I'm going to update our previous fib because we've now sort of moved forward a step to be the next one. All right, and once this for loop is completed, we can just return fib. So this fairly standard iterative method of doing a Fibonacci, but now we've written that, we might want to test that we can we can build our project. So we're going to go and write Gradle Build again, and oh dear, it seems as if I've missed out a semicolon. Thank you, Gradle, for helping me there. Oh god. Let's try that again. All right, so this is the error message that I wanted. Fantastic. All right. So what you'll see here is it's tried to compile our tests, and it's found that it can't find the method some library method anymore, which is obviously what we'd expect because we got rid of it. What we can do for the moment, and this is not good practice in general, but you can write Gradle Build -x test, and that will basically tell it, don't run these tests, just run the compilation step, and make sure that that works. And that will work. This obviously isn't great practice. One situation where you might want to do that is if you wanted to separate your tests and your build. Maybe your tests take really long and you don't want them to run at every build, which would be reasonable. But in general, we don't want to do this. So let's go and update our test method. So quite a few of you had worked with JUnit before. A lot of this syntax isn't really very important. The main important thing here is this assert true. And basically what that function does is it runs this argument here and it makes sure that what it returns is true. And if it doesn't return something that's true, then it's going to not be happy and it's going to tell us that that's not very good. You can also do assert equals and give it two things, and then it will evaluate both of those two things and make sure they're the same. And that's what we're going to do now. So we're going to do assert equals. And then our expected value, let's ask Java to give us the Fibonacci number of 10. So everyone knows that the Fibonacci number of 10 is 55. And then we're going to do class under test.fib of 10. And now we've got that, we can do our Gradle build again. And it will fail. Alright, so we can run, if we do Gradle build -- info, then it gives us a little more to work with. And here we can see that, not this again, it expected 55 and it's actually got the output of 256. Which means I've obviously gone wrong somewhere. So I'm going to do what I've been telling you guys to do all this time, and I'm going to copy and paste from the website. And well, hey, would you look at that? It's working. The nice thing about these unit tests now, as you saw before, is if your code isn't doing what you expect it to do, then your build is gonna tell you about this. You can imagine an example where some hotshot coder comes into the company and he says, I tell you what, you don't need that temporary variable. You can just do it like that. 2 lines of code, massive optimizations. Wow. And then they push this code up, and our build server goes, stop right there. That's not working. And before this sort of causes too many issues later on when we try and use a Fibonacci calculator, we're going to see it, and we're going to blame this person, and they're not going to work on our team anymore. No, you have a conversation with them and you fix the issue. So yeah, that's the nice thing about writing unit tests, and if you keep them up to date, they can be your friend. That's all that we're going to do today with setting up Gradle. The next thing we're going to move on to is getting started with Git and with Travis. So Travis is an online system which allows you to do testing for free if you have sort of an open source project. The wonderful thing about Travis is that it works natively with Gradle, and what that means is that you don't need to do any setup. You just sort of upload your thing to Travis, and it will just know what to do, which is wonderful. The thing that we do need to do before we set up Travis is we need to make sure that we have a GitHub repository containing our code that we can point Travis to. So I'm going to go back to my terminal, and I'm going to type git init, which is going to sort of create the Git repository. And then I'm going to do git status, and it's going to tell me all the things that I've got that Git knows about. And there's actually a lot of stuff here which we don't want Git to know about. So we have a lot of things which have been built by Gradle. We've got this build folder here. And there's a lot of reasons why you wouldn't want to upload that to your source control. So say someone downloads all of your build files from GitHub, but they're build files from an old build and they're actually out of line with the source code that you've got. That can lead to some really confusing bugs because you're trying to debug something that isn't what it says it is. Also, if you're on a bad internet connection, trying to download loads of build files from GitHub, it can take a long time. And it also can really not be very good for your Git history if you're constantly changing all of your build files every time you make a change to your source code. And so basically there's no reason to have your build files and all of that sort of gunk on your Git repository. when you can just generate them with Gradle Build commands. So what we're going to do is we're going to put a git ignore in, and this is basically telling Git, please don't look at these files, and that's going to be telling Git about our sort of build directory and all of the rest of it. And rather than having to do this ourselves, we can go to this wonderful website called gitignore.io. And sorry, the link on the work through is actually broken. So if you just go to gitignore.io, it will take you there. And then we're going to write Gradle. And it's generated this lovely little file for us. So we're just going to copy that, go back to our editor, and we're going to create a new file called .git ignore, and we're just going to paste contents that was generated by gitignore.io into that. And then, so if you've got a nice sort of visual thing like VS Code, you'll see that these build and Gradle directories are no longer green, and that basically means that Git has started ignoring it. If you don't have that, you can just do git status again, and you'll see that we no longer have that build directory here. So now that Git's ignoring that stuff, we can add all of it and commit it. These are all stuff that we want Gradle to know about. So, like I was saying earlier, build.gradle has a lot of stuff about that Gradle needs to know in order to do the build. If you add a new dependency, you want to make sure that everyone has access to that dependency. And our Gradle wrapper is that thing which initializes our Gradle when we don't have it installed, and you want to make sure that everyone has that too. So what we're going to do now is we're going to go to GitHub, and we're going to give ourselves a new repository. This is me. And we're going to just click on this little plus and then click new repository. Let's call it CI Workshop. And you can leave all of the settings at default. Now, here you've got a bunch of options of things you can do. Now, this is the one that we're interested in because we've got an existing repository that we have just created, and we want to push it from the command line. So I'm just going to copy both of these and paste them into my terminal. And then that's going to send all of my stuff to GitHub. And you can check by refreshing this page. And there it all is. The next thing we're going to do is we're going to head to Travis. And we're going to see how we can set this up. So I've got travis-ci.org open. And you'll see that, I've got a couple of projects here. Hacks at Cambridge website is one of them. The next thing I'm going to do in order to try and find the project that I've just uploaded is I'm going to click on my name in the top right-hand corner. Yep. Then what you can do is you can go to this page and you can click Sync Account. And hopefully that should, but if you sort of refresh your page a bit and click that button, eventually you should see your repository with a little button next to it that you can then just switch. Oh, hi, look at that. So I'm going to switch over that little thing, and now if I go back to the home page, I should see, over here, I have a little option, and this is where I'm going to see my builds. But there aren't any builds at the moment, which is an issue. So there's a link on our worksheet to this documentation for setting up Travis with Java. And if we have a look at that, we can see that what Travis wants us to do is add this one file called .travis.yml with the contents language Java. And I think you can figure out, what this is for. It's basically just telling Travis that we're building a Java project. And so what we're going to do, just go back to our wonderful editor and create a new file. .travis.yml. And then I'm just going to copy and paste that in there. And then if I go back to the terminal, I can see that I've got this thing which I need to add. I'm going to add it. I'm going to commit it. And then I'm going to push it up to GitHub. Now, if I go back to GitHub, I can sort of convince myself that that's now there. And if I go to Travis now, and I reload the page, then in a minute, this is going to start building. Well, hey, look at that. I shouldn't sound so surprised. I've done this quite a few times. So yeah, and what you can see here is you've got some output from where your tests are running. And this can be really useful if it starts breaking. For the moment, it shouldn't start breaking. Just got to give it a little bit of time to run the build first. And you'll see now that I've got this lovely green badge next to the name of my repository. It takes a little while to filter through. So you'll be happy to know that we're almost there with the content of this workshop today. The last thing I wanted to do is just quickly walk you through. You may have seen something like this if you go to GitHub repositories occasionally, where you have this build passing badge at the top of the description. And it's actually really easy to have sort of a live version of that on your repositories. And the way you do that is if you click on the badge, it will give you this little pop-up. Then the next thing you need to do is just select Markdown and copy the text that it generates for you. Then you can head to your GitHub repository, and you can do this in the command line and in your editors if you want. But a really easy way to do it is just to click this Add a README here. It's going to give you a title, and then we're just going to paste in that text that Travis generated for us. And we're going to save it. So I'm going to go here, create a commit, and commit new file. And now I've got this live indicator, this live badge of what the build status of my project is. Just like to say thank you all for coming. A big thanks for Hags at Cambridge, and especially to Tom, who created this workshop content last year, ran it, and I attended it, and it was very helpful for me, and I hope you guys also find this helpful as you go into your group projects. There's a feedback form which I think you can get to from the website. We really appreciate it. Can you? Okay, so yeah, thank you very much.